Today I had a coding interview. I didn't do very well on it, but I thought I'd review what I did, see if there's anything I can do better, um, and just put out there. It's a really simple exercise. I'm surprised it was difficult for me. Um, After I finished the interview, I went for a walk. I had lunch. I took a nap, and then I thought of something that could have made it a little bit better, but I don't know how much better. So let's go ahead and take a look at this. So I'm going to be using Python today. All right, Python interview folder, open Visual Studio Code. There we go. Getting started. Yes, I trust the authors. So I'm going to just work through the coding exercise that I had today. I'm going to create a new file. Well, I'm going to call this socks.py, and you'll see why in a minute. So the challenge was to, you're given a basket of socks, an unknown number of socks with an unknown number of pairs. So you might have red socks, blue socks, green socks, black socks, they never get dirty, white socks, etc. And your job is to sort these socks, to put them into matches. So every time you reach into the basket, you get a sock, one sock at a time. And when you pull out a sock, you want to make sure that if you pull out a second sock and it's a match, you make a match. You get the pair and you set it aside. And you go through the entire basket of socks until it's done and find out how many matches of which kind you have, right? So criteria one is you have a basket of socks. Number two, pick a sock out of the basket. Here, let's put some more. There are a random assortment of socks. They may have pairs. Pick a sock out of the basket. Keep picking socks one at a time until you have gone through them all. Let's make that bigger. And then every time you find a match, put them together and set it aside. Right? So first thing we do is we create a basket of socks. And I was like, well, how many socks, right? How many types of socks do they all have matches or whatever? And he said, well, just random stuff. And he said you can use an array or a list. I think he said a list. A list to represent the basket of socks, right? And so I'm like, okay. My thought was, I need to look up how to use random. Is it like math.random.randint or whatever? And I didn't know, and it was some online tool that didn't have nice code completion, right? So if I type, if I were to do it here in my editor or in IPython or something, right, I can say import or I do import math or I'd say from math.random, and I'd see really quickly that I'm on the wrong track. So a quick search told me from random import randint, right? And that gives me, so I can create a random selection of socks. So that was the first thing that tripped me up. I got a little caught up on what's the actual library for generating a random basket. And the interviewer said, well, it can just be a random selection of socks, right? Make an array of integers, right? So I've got, I was like, how about 100 socks with 10 types? So I'd like 6, 7, 8, 9, 10. And well, now I don't want to do 100 of those, so how am I going to populate this basket? And I said, how about we just drop it down to 4? I do 1, 2, 3, 4, 1, 2, 3, 4. So this is my simple test case. I have 4 different types of socks. Sock 1, sock 2, sock 3. This could be red, blue, green, yellow. And I have a pair of each, right? So this is one test case using a simple scenario. And then, well, I want to go through 4 sock in basket. Now, this was my next trip up, is I want to go, I wanted to like go through keys. And of course, an array doesn't have keys, or a list doesn't have keys. But for sock in basket, I can print sock, right? And let's just test this here out now. So I just run this, and I get a list: 1, 2, 3, 4, 1, 2, 3, 4. So I'm doing good. I'm going through my list of socks, right? I was still kind of set on the random. Okay, now how do I get a pair for each of these? Well, my first thought was, well, if I know what I have, right? I can duplicate this, right? So I have 1, 2, 3, 4, right? Because I know that I have, and I can collect my matches. But having just a list doesn't quite work out, because I need to keep track. Now I need to have another list, right? So I would have like sock types, and then I would have matches, and I would collect those. And I thought, well, wait a minute, this is just like collecting results. I think of like collecting test results, actually, right? For each test name, I have 1 or more test results, and I want to collect those test results. So I thought, well, I want a dictionary, right? I want a dict, or a dictionary, and I've been coding in other languages like Java, where you declare your type. So I do dict matches equals, and I'm going to create a dictionary. Now, again, I didn't have any IntelliSense code completion warnings to tell me, so I had dict here, and that was a big mistake, because of course in Python you don't have to declare types. I could do matches, and I could do dict, but I'd actually have to do like from typing, I think it is, import dict. That's how I'd actually, nope, it's not from typing. But anyway, I don't need types here. So I've got a dictionary, and so I say, well, now I need to check the keys, right? So, and I'm like, if sock in matches.keys, and I didn't, and I said, well, if not sock in matches keys, and I'm already thinking, well, I'm starting to get really convoluted here, right? And let's correct this: if sock not in matches dot keys, and he told me, the interviewer said, well, keys is also a function, which will give me the list of keys here. Then I want to do socks or matches sock. So I want to add to my dictionary, which is matches, a key, which is the sock I got, whichever sock I pulled out of the basket, if it's a 1 sock or a 2 sock or whatever. And then I would do plus equals, and here's the other mistake I made. I did equals plus, right? I'm like, well, you can't do matches sock plus plus. So you've got to do plus equals. Now I had another subtle mistake that happened. I did equals plus 1, and that looks on first scan fine, but you'll see what happens when it doesn't, right? So and I was like, well, and then if not, then we've got a match, right? So the idea is, well, let's just run through this and see. So I'll print matches after I go through my loop. Let me make this bigger. Wait a minute. I want everything to be bigger. I want my terminal output to be bigger. text editor, workbench, appearance, editor, settings, editor, search settings. Alright, time to Google this. I'm going to look for the output and Explorer font size in Visual Studio Code. Command plus, command minus. Code preferences settings. Alright, text editor font. Well, yeah, I've got that. Minimap. Alright, so they don't know. Maybe what I do is I bring this back down to whatever it was by default, and then I plus everything at once. Was it 14 or 12 or something to start off with? I don't know. Was it 10? Alright, so now if well, now it's going together. So that'll work for now. Okay, so for sock and basket, print the sock, I create a dictionary of matches, and then I do this. And you can see here, I've got one match of 4. Well, why do I have that? Well, first mistake is matches was in my loop. I need to initialize my dictionary, my collection outside the loop. Otherwise, I'm going to reinitialize it every time. So now we've got one pair of 1s, one pair of 2s, one pair of 3s, and one pair of 4s. Or rather, I've got one sock of each of those kinds. I'm expecting there to be 2. So I need to correct this error too, right? I need this to be plus equals. And then I get a key error. Why is that? I'm thinking. And this really had my head scratching. So the answer is, well, I can't add to a key that's not there, right? So, and this really looped me back and forth a couple times. But obviously, the answer here is to the simple answer is, and so I have something that looks like this, which I think will give me yeah, this will give me the right setup. 1, 2, 3, and 4 each have 2 socks. So now I have a collection, and I can actually test this. I can go 4, 4, 4, 4, and I'll add another 3 as well. And so I should have 3 3s, and I don't know, like 8 4s, 6 4s. And so we're doing good here. And then my next step was, well, okay, now I need to not just find out how many of each type of sock there is, but I need to get the pairs, right? And I said, well, I could take this set of matches and then I could break these down, right? I could modulus 2. And then I didn't actually get to this point. except it'd be like, well, we'll do key value in what it was in matches dot items. Well, let's do it. Print key value. Now I'm kind of stepping outside because I realized, and I said, you know, this would be the naive way to do it. I've got all my socks sorted by color. Now I'm going to put them into pairs. But I realized right off that that's not the most efficient way. So I'm going to look up loop through dictionary in Python. And I really depend on Google, especially because I switch languages and forget how to do this stuff. I need like iter items or something like that. So I could do in matches.keys, right? So I could print sock, and then I could print matches.sock. And you can see I've got 2 1s, 2 2s, 2 3s, and then I can say sock, and then I could say print. Well, I could probably all on the same line. I won't do it on the same line. Print sock modulus 2, and this will tell me how many pairs I've got for each one. So you have, and I do like a format string. You have of something like that. Let's see what that does. Yeah, you have 1 pairs of sock 1. You have no pairs of sock 2. You have 1 pairs of sock 3. This is really curious. You have 0 pairs of sock 4. Something's wrong here, because I've got, as you can see, I've got 1, 2, 2, 2, 3, 3, and so I should have 1 pair of 1, 1 pair of 2, 1 pair of 3 with 1 left over, and 3 pairs of 6 or of 4. 6 divided by 3. Actually, we need so I need to say you have matches.sock /2. Okay, this should work. You have now I have nothing. Everything's wrong. Let's clear that output and take a look at this. You have 0 pairs of 1, 0 pairs of 2, 1 pair of 3, and 0 pairs of 4. And then I always get bogged down on these simple mistakes. What's going wrong here? What if I just do divide by 2? You have 1 pair. Okay, so that's what's happening. I was doing modulus, so if it's even, it returns 0. If it's 1, I return 1, right? Modulus 2, so even or odd. It's just telling me even or odd. So I actually need to do something like, what would it be like? Is it math.floor? So now I would do like a so that would actually give me the correct amount. You have pairs of sock. Oops. Yeah, you have 2 pairs. I don't have 2 pairs of math sock /2. All right. You have one pair of sock 1, one pair of sock 2, one pair of sock 3, 3 pairs of sock 4. Let's add a couple more 2s in here. Okay, we'll add a 3 and another 2. Save that. So now I have one pair of sock 2. I have 2 pairs of sock 3, 3 pairs of sock 4. I also wanted to test an odd number. So I'm going to delete, I'm going to add a 2. So I should have an odd pair of 2. So it should say I only have 1, 2. Oh wait, I have one pair of 3, or one pair of 2, one pair of 1 because there's only 2 ones, one pair of 2 because there's 3, 1 left over, 2 pairs of 3 because there's 4 of them spaced out, and 3 pairs of 4. So this is pretty convoluted, and right, we don't actually need this secondary loop and this import math, actually, it turns out. So I'm going to remove all that, and I don't need to do, well, I'll keep that print matches at the bottom. What I want to do is I want to say, well, this occurred to me pretty quickly once I got past my hang-ups on filtering through this or doing it in a duplicate, right? So this would be like big O notation, O of n, and this would be like 2 O of n or something like that on that scale, or O2n. I don't know big O notation very well. And obviously we're going through the entire list twice. Well, we're not going through the entire list twice. We're going through the basket of socks, the list, once, and then we're going through the set of matches once, which is roughly half as big as the list. Anyway, so we go through and I'm like, well, if we're adding to it, that means that I now know that I have a match, right? If there's one in there and I find another one, I've got a match. And so what I do is if sock not in matches, and it turns out that matches.keys or matches works the same. It both works fine. And we can even test this. Come up with my right result here. And 1, 1, 2, 3. Good. Okay, we'll say goodbye to that again for the last time, I hope. So then we say, well, instead of matches plus equals 1, that right, what I'm saying implicitly here is I have 2 socks. I have a match. And I think I made something, I went through at one point and I just like, okay, I'm only finding if there is a match instead of printing another match. So I asked for reiteration, and he said, well, I said, what do we do? And he said, well, print you find a pair every time you find a pair. So you're setting it aside, you're printing it, or you're adding it to some other collection and removing it. So I said print found a pair. And I'm going to just add a format string here. You found a pair of socks. Sock meaning the color or the number we're using to represent the socks. And so this will work. So here let's clear this. It really doesn't like to clear. All right, so right, I go through, found a pair of 1s, 1, 1, found a pair of 2s, 2, 2, found a pair of 3s, found a pair of 4s, 4, 4, found another pair of 4s, another pair of 4s, and I also was going through this, and I don't remember how I got to that, but I was doing 4, 4. Oh, I was then deleting, and you can see this this list, but I was going through each one and finding a pair, and what I need to do is I also needed to do and I would go to the count equals 0, and yeah, and so here you can see it finds 3 in a row of the, oh wait, maybe that's just duplicating the output. All right, yeah, so, but it does do that. I find a pair of 1s, I find a pair of 2s, I find a pair of 3s, I find a pair of 4s, another pair of 4s, and another pair of 4s. So what's happening here, my mistake is that I'm finding a pair of 4s, I'm finding another pair of 4s, I'm finding another pair of 4s, and I'm only reducing the count to 1, and I'm not removing it, right? So my condition is that if the key exists, not if the number of socks exists. So I'm like, well, okay, how do I delete an entry, the whole key value set from a dictionary? And he said, well, use DEL. And that's about what I thought. I don't know if this is the most efficient way. It's just dropping a reference, or it's readjusting the size of the dictionary. So that might not be the most efficient way of doing it, but we go through that. I need to clear the output and run it again. I need to get rid of that mini map. Mini maps are terrible. Oh, here we go. Got rid of my mini map. All right, so here we need to clear my output, run again. I hate Visual Studio Code terminal. Okay, so I got 1, 2, 3, 4, 1. I found a pair of 1s. 2, I found a pair of 2s. 3, I found a pair of 4s. 4, I found a pair of 4s. So looking at this again, all right, I find a pair of 4s, and instead of finding a pair and a pair and a pair, I go 4, 4, and then I find another pair, or rather up here, but 4, 4. So now, because I'm deleting my key, I'm not assuming or getting pairs when I don't actually have another pair. I just have matching the first one, because the key existed even if the value is 0. So I could add more logic for the 0, and anyway, so I did a little bit of cleanup on this, and let me see. All right, I need to get rid of this print sock, for instance. So I found 1, 2, 3, 4, 4, 4, 3, and I've got, you see, 1. Because I'm removing all my matches, I have 1 sock 2 left over. All right, so I think this might have about been where we left off, and where he decided that I really probably didn't cut it in terms of what they needed. But he asked if there were any other optimizations, and I was like, I'm flustered, and this is clearly not the cleanest code. I can just tell from the way I'm doing this. This is not the cleanest way of doing it. So I thought, oh well. And we had a good conversation after that. But it was a learning experience for me. Definitely, not having the syntax in mind for Python. I didn't know what language they were going to want me to use. He had Python up, and about halfway through he said, well, you can use any other language. I don't want to switch to Java or whatever, or JavaScript. I'll run into the same sort of troubles with the context switching between syntax, and I already have Python half loaded in my brain. But this is essentially where I left off, and it works, but it's not ideal. And he wanted me to find, well, are there other ways to optimize? Well, I said, I could do something, if this is a huge stream of values, then well, we could increase the performance by splitting it up, parallelizing. If it was a stream, we couldn't parallelize per se, because they're coming in one at a time. But if it was a huge data set, we could break it up and run it in parallel. I couldn't think of anything, and I said, well, dictionaries, are probably not the most efficient. I actually went through and said, well, what if I don't, because of this, of getting the keys, I don't actually need a dictionary, right? I could just create another list, and every time I say it's in the other list, then I have a match, right? So now I don't have to generate this other set of this whole dictionary, right? It could just be another list. But then I caught myself and realized really quickly, well, wait a minute, to check if, right, if matches was a list, and I was getting, right, if I had a list of socks, as opposed to a list of matches, for sock and basket, I would do if socks, and then I'd have to search, right? If socks dot contains, I'm thinking, and I don't think that's valid. Like contains. Let's go ahead and try this out. The argument type int is not for sock in basket. If socks in sock. Oh, I've got it backwards. If sock in socks. 1, 2, 3, 4, 4. Alright, and I could do the same strategy, and I've got to do like string here to print it. But my realization quickly was that a dictionary is going to be more efficient. Even though a dictionary has more overhead, it will be more efficient than a list for finding the match in there, because, well, a dictionary is a hash table. You can randomly access and find a value in that. For a list, you've got to go through all the items in the list to make sure it's available. If it's 10 items, it's not a big deal, right? But you don't know, right? If you could have up to 1 million different types of socks, right? So if it's the case, if you have 2 types of socks and you know that, that's easy. Or you can pre-populate with your known set 1, 2, 3, 4, or 1, 2, or whatever. That makes it easier. And I'm getting into some fairly obvious things, right? Some simple computer science things that, well, searching a list is actually going to be not as easy as searching a hash table. So I said, we'll leave it a dictionary. And that's where we left off. Like, he was probably sick of my stumbling through the code. But to my point, I realized right off that going through and doing 2 loops was not efficient. Anyone should be able to realize that pretty quickly. I caught myself and realized that a dictionary is going to be more efficient to search if we have a match in that, right? I don't know, actually, maybe Python behind the scenes, when you do, if a value is in an array, it's handling it the same way that, or if a value is in a list, it's handling it the same way as if it's in a dictionary. So I don't know. He said Python dictionaries are very efficient. But then, like I said, after my walk and everything, and nap, the nap probably helped more than anything else, I realized there is one way. This is probably not the most efficient way to go through this, but I did think of something that would make it a little more efficient, and that is, well, what makes a dictionary, what makes looking in dictionary keys efficient? What do we know about the keys in a dictionary? And the simple answer to that is the keys in a dictionary must be unique. That's why we can create that that hash of the keys. And so I thought, well, I can mix the two, right? A list or an array is simpler than a dictionary, so we get that advantage. but to be able to search the item, to search the keys in a dictionary is an advantage. So we can use a set, right? A set, and so I had to look up. I was like, well, a set in Python, right? If I had a set, that's defining a set. How do you initialize an empty set? Because isn't that initializing an empty dictionary? I looked it up. I can create a set like this, and I can remove that because we're not going to use an array of different types of socks. We're going to use a set. So matches is a set, and then so for sock in basket, I can say if matches, or I could say what is it? If sock is not in the basket, and this is a little cleaner, right? Then what I do is I want to do to my set, to my matches, I want to add sock, and instead of calling it matches, I'll call it socks. So if a specific sock is not in socks, that helps. Then what I want to do is I want to do socks.add. So types of socks, add this specific sock. And then it's taking me longer to get to this than it did once I realized I had a set. Else, right? So I'm saying same thing I was doing before. If it's not in the dictionary, if the key is not in the dictionary, create the key and add one to the dictionary. So then the next thing I do is I say, well, then I just print found match of type sock, and then I can do socks.remove. And I don't know if socks.remove is cheaper than deleting. It feels cleaner to me. So what I'm doing is saying, if I don't have a sock that matches this, hold it. I don't have a green sock, or I don't have a 1 sock, hold on to this green sock. I don't have a red sock or a 2 sock, hold on to that red sock. I don't have a 3 sock, then I'm just going to keep collecting them up to my size, potentially up to my size, right? I may never get to my full size. I might do 1, 2, 3, 1, 2, 3, 4, 4, in which case my set will only ever have a maximum size of 3 because I'm removing the items before I'm adding more. So there might be some room for optimization there. But anyway, now every time I have an unmatched sock, I add it to the set. Every time I find a match, in other words, when I already have a 1 sock or a green sock or a black sock, whatever it is, I find the match and I make a pair and I remove it from the set. So this was essentially my best case that I could come up with. I feel like there's probably a known computer sciencey way of doing this, but there's a way, like if you know your algorithms correctly, that you can filter this basket of socks easier. But this is pretty straightforward. It reads pretty nicely, and it's fairly efficient. It combines both the efficiency of the list and of the dictionary, at least hypothetically. I don't know how Python handles it underneath. It may not be any more efficient. But that's my solution here. I'd love to hear if anyone else has a better solution, and I'll print this solution online and see if anyone can come up with it. Oh, one other thing I did when I worked on this is I'm like, well, you know, I actually want to test this. So I looked up, I want to import random, right? I don't want my basket to be like this, and I want to use a random.seed so I can recheck it. So I can say seed 1 or seed 101, whatever it is, and that way it'll always test the same way. And then I can say basket equals, and then I just do random.randint, and I can say, right, I can say 1 through 4 for I and range, you know, I can say 100 now. For I in range. There we go. And now I can, I'm just going to hop back over to my terminal where I'm happy, and they're not, what? Command not found, Python. Why? New computers. All right. I'll just do Python 3 and then what is my file? Socks.py. Found match. And I wanted to see my original list so I can check against it. That's obviously too long. I need like a range of 10. There we go. So I've got a match of 1, 1, 1. I've got a match of 4, and then another match of 4, and then I've got a match of 2s. So that looks pretty good. And 1, 4, 4, 2. And it comes out the same each time, but I can change my random seed or eliminate my random seed, and it'll at least be pseudo-random. There we go. All right. Let's go ahead and add this to Git. I think I don't have the GitHub extension. I don't know what the right extension. Anyway, I will just quickly go over here and make a gist. Create public gist. All right, here we go. Here's my gist in GitHub. So we can look at that, and I'd love to see what people come up with as better solutions. All right, that's it for today.